This is a continuation of a very long-term project. This is something that started years ago in SURF and that Harry was leading for a while, but it's a really big, complex organization, and efficient planning of organizational resources depends on coordinating the planning in a holistic way where the needs and planned growth of each department are considered and how they're going to interact with the needs and the growth of other departments. So the students did an amazing job kind of learning the complexity of our system, not just operationally what happens, but also the additional layer of complexity of how there are many different ways to define the same thing based on what kind of operation or planning reason that definition is going to be used for. So they handled this incredibly well, at the same time, again, dealing with the challenges of the quarter, and they're going to present the results of their work as well as an exciting tool that I believe the institution is going to build on and develop.
Thank you, David. Thank you. Okay, so we're a capacity planning group. So yeah, I'm Valerie.
And I'm Jenya. We had a number of stakeholders involved in this project because it covers pretty much the whole hospital. It was primarily the patients, as well as care providers, administrative support personnel, sponsors and investors, as well as hospital administrators and our direct project sponsors, to whom we're very grateful for their continued support throughout this project.
So we had one overall objective, which was to project OR demand and patient days based on historical growth, projected growth and provider recruitment. And under that, we established 3 sub-objectives. One, which was understand hospital patient flow. The second was complete descriptive analysis of historical hospital data. And the third one was to build a user-friendly volume and OR time projection function. So to tackle the first objective, we looked at patient flow, and this included doing a tour of the hospital and then creating this diagram. So there's 4 primary colors, and orange, blue, and red each represent different patient classes, and then purple in the diagram is kind of supposed to represent all the paths that all classes can take. So basically the point of this diagram is to show that the different patient classes take different routes for entry. So, and then for the historical analysis, we first started with looking at procedure volume over time. So on the right, you'll see the total procedure volume stacked by primary service, and we were primarily looking at cardiology, electrophysiology, interventional radiology, and then 2 like sub-interventional radiology, neuro and pain. So obviously it's pretty steady, and then on the left, it's broken down by inpatient and outpatient, which have inverse fluctuations, so that overall amounts to the steady total. And then here we looked more specifically at procedure types, and kind of the same as what was on the last slide, where there's variable procedure growth trends, but overall they're complementary and amount to the steady volume.
Then as the next step for our projection function, it was also important to evaluate historical data to do with length of stay and demand that patients generate. First, we looked at the average length of stay in the hospital split up by primary service. And from this diagram on the slide, you can see that medical admits tend to stay in the hospital the longest, and especially in the cardiology service. And then as a second step, we also looked at not only primary service, but also department that people stay in. And from here, we found that patients tend to stay the longest in NICU, in HEMONC unit, which is oncology, and as well as CVICU. And then we also looked at the ORs and the utilization specifically for these ORs. There is 5 of them that are primarily involved with cath-IR patients. And from our analysis of the utilization, we found that the current OR utilization highlights an opportunity to increase patient volume in the future.
So one of the main inputs for the function is providers. And so we looked at the average case volume or the average case minutes per provider. And in this graph, it shows the providers broken down by specialty, and any provider that had less than 100 cases, we lumped them into an other group within their specialty. So overall, this is showing that specialty and not the individual providers, that's kind of the main determinant of OR use time. Okay, so next, we were looking at the association between the different service lines. So in this graph on the y-axis is the base primary service. So to calculate this, the values in this graph, we looked at a patient's first visit to a given service line. So that would be the base primary service. And then we tallied kind of the subsequent visits by service line, and that's would be the subsequent primary service on the x-axis. And then we figured out like the fraction, so or the rate per 100 patients for each service line. So as you can see here, the cath-IR patients tend to get repeated cath-IR procedures as well as neurosurgery and cardiovascular. And here, the axes are switched where the base primary service is on the x-axis and the subsequent is on the y. So we can see here that the pain management and transplant patients tend to receive IR care, and overall, patients tend to visit IR like across the board after visiting the ones on the x-axis.
And then finally getting to our projection model. So we developed an interactive model that is able to simulate OR demand and patient days, so length of stay, generated by hiring new providers. And we apply this model specifically to cath-IR patients. However, it can be used for any other service as well. Here is an overview of the model. The two major outputs that it was supposed to produce and produces are the projected case volumes, as well as the projected usage time, depending on how many new providers we hire. And for inputs, we have the number of new providers that we're hiring, the base year from which to base the projections from. Then we have similar providers. So for each new provider, there could be one or several providers that they're similar to in volume and types of patients that they're seeing. And we have the similarity fractions of how similar they are to the providers. And then we have the start dates for the new providers when they start in the future. And we also have the case volume percentage from the reference. And that just means that when a new provider starts, they might not start from 100% of the volume of their similar provider. They might start at say 20%. The next year they'll gain just like 60%, and then third year they'll get to 100. And overall, this gives us projected case volumes and projected room times for ORs as well as for departments that patients stay in. So this is a brief overview of what the model does. We made it runnable from command line to abstract it a little bit from the underlying code. And it produces an interactive dashboard that you can see in the image here. And there's also an option to save the outputs. And for saving the outputs, there's our projections. And there is also an option to save the historical analysis that we just went through in this presentation. And that would be useful if, for example, the model is used next year, so the data gets updated and the new historical analysis would be useful to do. Here is an example of the model outputs for ORs specifically for the input that is provided in this table. So we're plotting patient volumes and we're plotting use times for the ORs from the years of 2019 through 2031 based on the following inputs. So we base our projections on 2021. We have 3 new providers that are getting hired. And if we just look at the first provider is similar to some provider A, some provider B. They start in June of 2023, and they gain their volume from first year that they start as 30% and 70% and 100%. And the degree to which they're similar, of how they're similar to provider A and provider B is 30% for provider A and 70% for provider B. And that gives us this type of output that we can see how the patient volume increases through the years and also how the use time for the ORs increases. And the next type of output is the bed units, specifically departments that people stay in, such as acute care, ICU, and so on. Also similar input and similar types of projections, except for instead of outputting the use time, we actually output the average number of beds that would be required to have in the department to serve all the patients that are going to be generated by the new providers. Thank you so much. Do you have any questions?
So I took part in the planning for the opening of Packard 2.0, as did many others. And this question of how to plan when a given surgical service is going to hire somebody and how to plan for that volume is one that we dealt with over and over. And it was always anecdotal. Oh, we're going to hire this person. Oh, well, they're going to be similar to this person, I guess, if you think to ask. Oh, they'll ramp up their volume this fast because they're going to do research versus clinic days. Or they'll never ramp up their volume because they're going to be half research and only half clinical and so on. And this function you've built is just a fantastic way to incorporate systematically all of the different considerations that in the best case, people think about and input when hiring, but in the most common case, they don't, and end up having to be worked out after the fact. So I think it's going to be incredibly useful. And I really look forward to working with Miko, who's a fantastic partner to you all in this project, to see if this can be built into something that the hospital can use and can be made available broadly.
Thank you, David.
Yeah, thank you.
Thank you. Let's thank the speakers once more.